Wade.
Hey, Carly.
Let's now use the correlation coefficient to help make predictions of y variables.
I think we're talking about learning now.
Yes, so we're gonna look at a technique called linear regression, and specifically we're gonna look at the regression line and how we can use that to make predictions. Given any x, what do I predict for y? So linear regression is the idea of trying to fit a line as closely as possible to as many points as possible. And the most common technique to do this is a technique called ordinary least squares regression. And basically what this means is that we're going to fit a line of best fit through our points that minimizes the error between each point and the regression line. So we can make predictions once we have this line of best fit. And we can also represent it as just a line in slope-intercept form. Since the line of best fit is just a regular straight line, we can think of it in the form y equals mx plus b. And in statistics, we actually don't use n and b to represent the slope and the y-intercept. Instead, for the slope, we use something called b1. So this represents my slope. It's the term attached to the x. And then for the y-intercept, we use something called b0 or b0. And the reason we use these little b's instead of y equals mx plus b is so that we can always refer to the intercept as b0. And then the slope, depending on if we want to add more slopes, we could potentially add a b2x2 or a b3x3. The slopes allow us to do multiple regression and add more parameters.
So this could go on forever.
It could go on forever. Yes, for sure. And I'm going to talk about how to calculate these things, the slope and the y-intercept of these regression lines, mathematically. And then we're going to see how we can do it in Python. But it's always good to make sure we understand what exactly Python's doing and the math behind it. So the slope of the regression line, the way we get this b1 is just by taking the correlation coefficient multiplied by the standard deviation of y and divided by the standard deviation of x. And then to find the y-intercept of the regression line, so this is b1, this is b0, we're just going to take the average of y minus that slope that we just found times the average of x. And before we get into an example, I want to just mention how to interpret both of these things, because it's one thing to find them, it's another thing to be able to understand what they mean. So the slope, it says, is the average increase in y associated with a 1 unit increase in x. So if we were looking at height and weight as our example, and let's just say we have height on the x-axis and weight on the y-axis, the slope of the regression line, whatever regression line best connected the points, would basically be the average increase in weight associated with every 1 unit increase in height. The y-intercept is actually the point where the line crosses the y-axis. So it's the predicted value of y when x is equal to 0, right? Because at this y-intercept, we've gone over nothing in the x direction, our x is 0, and then our y-intercept is that y value. So I think we should do an example. This is going to help us figure out how we can do regression estimates or make predictions and what it means to incorporate the correlation coefficient to do that. So puzzle 1 is looking at the classic diamond data set, and it says we've already found the 5 summary statistics. We found the 2 averages, the average carat weight and the average price, the 2 standard deviations, and then the correlation coefficient R. And we see that our correlation coefficient is 0.92, meaning that the price and the carat weight have a pretty strong correlation. As the carat weight goes up, the price also goes up. So it says, let's go ahead and calculate the regression equation. So in order to do that, we basically want to find y equals mx plus b. And it doesn't matter which order these are in. We could do b0 plus b1 times x as well. But to find the slope, b1, I'm just going to do my correlation coefficient times SDY over SDX. So Wade has Python pulled up as a calculator, and he is going to go ahead and plug in 0.92 for R times, and then the SD of x and y. We have to figure out which one's x and which one's y. So Wade, how do we know Is the first one always X and the second one always Y?
I would look at the graph is how I would look at it.
That's probably a much better way to do it. So it looks like I have price on my Y-axis and and carrot on my X-axis. So the first one isn't always going to be X. In this case, it does happen to be that that's the case, but the graph is a good way to tell you exactly what you're predicting. Or if you look at the questions, Y is always what you're predicting. So I'm even going to write that down. Y is always what you're predicting. And X is what you're using to make that prediction. So the SD of Y in this case is price, so that is 3989, and then the SD of X is 0.5. So Wade, if you could let me know the slope, that would be great.
0.92 times 3989 divided by 0.5 is 7339.76.
7339.76. So I'm going to go ahead and add that to my equation. I have 7339.76x plus, and now I need my y-intercept. So to find the y-intercept, I can look at the formula from the other page, or I can say, well, this is what I have. I have y equals 7339.76x plus my y-intercept. I just need to plug in something for x and y in order to get B0 by itself. So the only thing I'm given are the two averages. That's the only point on this scatter plot that I know. So I can plug in the average value for y. So I can plug in 3933 for y. And then I can also plug in the average value for x, which is 0.8. Plus B0 to find B0. Wade is putting that into Python.
So I'm rearranging the equations a little bit and doing 3933 minus 0.8 times 7339.76. Is that right?
Perfect. Yep.
And I get negative $1,938.80.
All right. So I am going to add that to my regression equation. It's actually minus $1,993.80. So here is my regression equation. So this is the equation of this line in slope-intercept form. So why did I care about that? Who cares what the equation of this line is? Well, the nice thing is I can use this regression equation to make predictions. It says to use the regression equation to predict the price of a diamond that is 2.5 carats. So this is saying if x is equal to 2.5, if I know x is 2.5 carats, what is this value of y? And I can look at my graph and kind of estimate it, but I don't know the exact value. But what I can do is just go ahead and plug in x into my equation and it will give me a y. So I have y equals 7,339.76x. For x, I'm going to plug in 2.5 minus 1,993.80 to get my predicted value.
1,938, sorry.
Yes.
Okay, awesome.
Oh, 1,938.
I may have told you a wrong number.
Oh, okay. 1,938.
And then I get $16,410.59.
So that means I predict that if a diamond is 2.5 carats, which is pretty big.
It's a good sized diamond.
Yeah, it's around $16,000. And looking at my graph, that prediction looks just correct. It's just under 20,000 on the graph, and now we know the exact value. So we can plug in any x value into this equation. Python will give us a y value. It's definitely best to only plug in x values within the range of our data set. Like if we wanted to predict a 10 carat diamond, that would not be good to do with this data because we don't have that data. But we got $16,000 for our prediction.
Seems reasonable.
Seems pretty reasonable. And then the last part of this little puzzle says, how do you interpret the slope and the y-intercept in the equation above? And this is good to take note of. So the slope is the average change in y for every 1 unit increase in the change of x. So the slope, I'm going to say, is the average increase in price for every 1 unit increase in carat. So the price goes up about $7,000-ish for every 1 unit increase in carat. And then the y-intercept here is kind of weird. It's a negative number. It's negative 1,938.8. And the y-intercept is generally interpreted as the value of y when x is 0. So the average value of price for a 0 carat diamond, which doesn't make sense. And we did not have any of those in our data set. So it kind of does make sense that our y-intercept doesn't have a great interpretation, because in order to predict for a 0 carat diamond, that wouldn't be a good prediction because it's not in our data set and it's not actually a thing.
I would love to get $1,900 for nothing.
Yeah, exactly. And then just a very quick last thing to say about regression. I want to give you guys a warning about regression. We've mentioned this briefly, but predicting y values beyond the range of x in the data is called extrapolation, and this is very risky because we have no evidence that our linear relationship continues for unseen values of x's. So you definitely want to make sure not to extrapolate, because that could be one way to lie with statistics. It says extrapolated predictions can be absolutely wrong. So we definitely don't want to do that. And that again explains why the y-intercept interpretation doesn't really make any sense.
So if I go into a jeweler shop and tell them that Carly told me a 25 carat diamond should only cost $30,000, they wouldn't be a fan?
They might think you're crazy. So that is an example of linear regression, doing it by hand, and we're going to dive even more into this in Python.